Dear students, so first and second modules are already over. Now let us discuss third module. In this module, we are mainly focusing about the infinite series and the test for convergence. So, what is a series? Series is nothing but consider that a1, a2, etc. an is a sequence. Then a1 plus a2 plus etc. plus an is its corresponding series. So, the infinite series means the infinite series that sigma n ranges from 1 to infinity xn. So, this is an infinite series x1 plus x2 plus etc. and so on. So, it is sigma n ranges from 1 to infinity xn is an infinite series, or if the limit of this series is not mentioned, sigma xn, then we understood that it is an infinite series. Agreed. So, let x equals xn, if x equals xn be any sequence of real numbers, then the infinite series generated by x is the sequence s equals sn, where sn be the nth partial sum of this x1. Nth partial sum. If x equals xn be the sequence of real numbers, then the infinite series generated by x is the sequence s equals sequence sn, that is defined by what is s1? s1 equals x1. What is s2? s2 equals x1 plus x2. What is s3? s3 means x1 plus x2 plus x3 etc. What is sn? sn equals x1 plus etc. plus xn. So this is the nth partial sum of the given sequence x equals x. Okay. So it is usually denoted by the infinite series is sigma n ranges from 1 to infinity xn, or simply sigma xn. Enough. Now the series sigma xn converges. Here sigma xn, understood, it is an infinite series. The sigma xn converges if its nth partial sum or simply its partial sum converges. Means, if the partial sum of a series converges to a particular limit, then the infinite series converges to the same limit. Agreed. So when the partial sum converges, then the series converges. When the partial sum diverges, the series also diverges. Agreed. So for consider sigma minus 1 power n. Sigma n ranges from 1 to infinity, or simply sigma minus 1 power n. What is s1 here? Here s1 equals minus 1. Okay. What is s2? s2 equals s2, s1, x1 plus x2, minus 1 plus 1, that is 0. What is s3? s3 is minus 1 plus 1 minus 1, so it is minus 1. What is s4? s4 is 0. Clearly, the partial sum does not converge. Means here Sn, sequence Sn means the partial sum Sn of this given series is diverges, means Sn diverges, so the given sequence, the given series is also diverges. Okay. Consider another one. Consider sigma 1 by n into n plus 1. Consider this series. Sigma 1 by n into n plus 1. How? So, actually what is 1 by n into n plus 1? 1 by n into n plus 1 means 1 by n minus 1 by n plus 1. Okay, n plus 1 minus n by n into n plus 1. So, it is 1 by n minus n plus 1. So, what is S1? S1 means 1 minus 1 by 2. Sure. What is S2? S2 means 1 by 2 minus 1 by 2. So, what is Sn? Sn equals 1 minus n means x1 plus x2 plus etc. means plus Sn. So 1 minus 1 by 2. Now plus 1 by 2 minus 1 by 3 plus 1 by 3 minus 1 by 4 plus etc. plus 1 by n minus 1 minus 1 by n. 1 by n minus plus 1 by n minus 1 by n plus 1. Agree. So you can cancelling all the terms except the first and last. that is Sn equals 1 minus 1 by n plus 1. So what is limit Sn? Here limit Sn equals limit 1, that is 1, minus limit of 1 by n plus 1. When n tends to infinity, it should be 0. So limit Sn equals 1. Means the partial sum converges to 1. Therefore, the given series sigma 1 by n into n plus 1 also converges. So here we see that when the partial sum of a series converges, then the series converges. Means the series xn, the infinite series xn converges when its partial sum converges, otherwise it diverges. Okay. So, according to these arguments, consider a result that x equals xn and y equals yn are any two sequences such that sigma xn and sigma yn converges. Let sigma xn converges to x and sigma yn converges to y. Here yn means, sigma yn means infinite series. Sigma n ranges from 1 to infinity yn. So sigma yn converges to y. Then to show that, then we have sigma xn plus yn that converges to x plus y, and sigma cx converges to, sigma cxn converges to cx, where c is in a constant. How? Here sigma xn and sigma yn are infinite series. They are converges. So let Sn be the partial sum of sigma xn. Sn be the partial sum of sigma xn, means Sn equals x1 plus etc. plus xn. Let Tn be the partial sum of sigma yn, that is y1 plus etc. plus yn. Since sigma xn and sigma yn are converges, surely Sn converges to x and Tn converges to y. Okay? Why? Because sigma xn converges to x and sigma yn converges to y. Now, what about sigma with respect to n xn plus yn? Sigma with respect to n xn plus yn. So, that equals sigma with respect to n xn plus yn means it is x1 plus y1, okay, plus next term x2 plus y2 plus etc. plus xn plus y. Agree? That equals it is x1 plus x2 plus etc. plus xn plus y1 plus etc. plus y. But what is x1 plus x2 plus etc. plus xn? That is Sn, which converges to x, plus y1 plus y2 plus etc. plus yn converges to y. So sigma xn plus yn converges to x plus y. Sigma xn plus yn converges to x plus y. Similarly, you can prove that sigma cxn converges to cx. Okay? Right. So, when sigma x and sigma yn are infinite series which converges to x and y, then sigma xn plus yn converges to x plus y, as well as sigma c into xn converges to cx. Agree? Now we consider an nth term test. Nth term test. What is an nth term test? That's an important result. Important result according to the series. If sigma xn converges, then limit xn equals 0. This is an important result regarding this regarding the series. If sigma xn converges, then limit xn equals 0. The reverse inclusion need not be true. When limit xn equals 0, that need not be implies sigma xn converges. But when sigma xn converges, limit xn 0, that is nth term test. Here xn is the nth term, Sn be the nth partials. Okay. How this one? How to this prove? So consider sigma xn. That's an infinite series. Then let Sn be the nth partial sum of the given series sigma x. Since sigma xn converges, let sigma xn converges to some x. let sigma xn converges to some x. Since Sn be the nth partial sum of sigma xn, surely Sn converges to x. Okay. What is Sn? Sn means it is x1 plus x2 plus x1 plus x2 plus etc. plus x. That is Sn. And so what is Sn minus 1? Sn minus 1 is x1 plus x2 plus etc. plus xn minus 1. Okay. So what is Sn minus 1? Sn minus Sn minus 1 is simply, it is xn. All the other terms are cancelled. Now, therefore, taking limit on both sides. So it is limit Sn minus 1 equals limit xn. Okay. What is Sn? Sn converges to x. So it is limit Sn minus limit Sn minus 1 equals limit xn. Clear? Yes. Sn converges to x means limit Sn is x. So limit Sn minus 1 is also x. So equals limit xn. That means limit xn equals 0. So when sigma, this is the nth term test. When sigma xn converges, then limit xn equals 0. Agreed? When sigma xn converges, then limit xn equals 0. So this is used for testing the convergency of some of the series. It is not valid for every series. Suppose it is valid for some of the series. The nth term test is a simple test for testing the convergence of a given series. That is, when sigma x and sigma, the given series converges, then limit of its nth term should be 0. Sigma xn converges, then limit xn equals 0. What about the reverse inversion? Reverse inversion need not be true. When limit xn equals 0, need not be implies sigma xn converges. So this can be proved by using an example. So consider series. Let x equals sigma 1 by n. Okay. Sigma 1 by n. So its nth partial sum, Sn. N is 1 plus 1 by 2 plus 1 by 3 plus etc. plus 1 by. Okay. What is S2 power n? S2 power n is 1 plus 1 by 2 plus 1 by 3 plus etc. plus 1 by 2 power. Okay. Surely S2 power n is the subsequence of Sn. Agreed? Sure. Clearly, S2 power n is a subsequence of Sn. So when Sn converges, S2 power n also converges. Or when S2 power n converges, maybe. Now this S2 power n equals, this can be rewritten as, this is 1 plus 1 by 2. Okay. Plus the next term is arranged as 1 by 3 plus 1 by 4. Plus next term is 1 by 5 plus 1 by 6 plus 1 by 7 plus 1 by 8 plus etc. plus etc. plus 1 by 2 power n minus 1 plus 1. 1 by 2 power n minus 1 plus 1 plus 1 by 2 power n minus 1 plus 2 plus etc. plus 1 by 2 power n. Okay. 1 by 2 cube, 1 by 8. 1 by 2 square plus 1, 1 by 5. 1 by 2 square plus 2, 1 by 6. 1 by 2 square plus 3, 1 by 7 and so on. So, this S2 power n can be arranged as, it is 1 plus 1 by 2 plus 1 by 3 plus etc. plus 1 by 2 power n. That is arranged as in this way, 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by 5 plus 1 by 6 plus etc. and so on. So it should be strictly greater than 1 plus 1 by 2 plus 1 by 4 plus 1 by 4. Okay? Strict inequality. Plus it is 1 by 8 plus 1 by 8 plus 1 by 8 plus 1 by 8. Okay? Plus etc. plus 1 by 2 power n plus 1 by 2 power n plus etc. plus 1 by 2 power n. Okay. That equals 1 plus 1 by 2 plus 1 by 4 plus 1 by 4. Again 2 into 1 by 4 means 1 by 2 plus 1 by 8 plus 1 by 8 plus 31. That's again 4 into 1 by 8 means again 1 by 2 plus etc. plus, come on, plus etc. plus 2 power, this is how many terms are there? 2 power n minus 1 terms, so it is also plus 1 by 2. So that equals 1 plus how many terms are there? 1 plus how many 1 by 2s are there? There are n 1 by 2s, so it is 1 plus n by 2. It is 1 plus n by 2. Agreed. So 1 plus n by 2. S2 power n equals 1 plus S2 power n strictly greater than 1 plus n by 2. Its meaning is the sequence S2 power n is unbounded. It is unbounded. So S2 power n is a subsequence of Sn. Clearly the secant Sn is unbounded. Sn is unbounded because of this one. Because S2 power n is a subsequence of Sn. Okay. Secant Sn is unbounded. Secant Sn is unbounded means secant Sn does not converge. It does not converge. So, but here x equals, what is xn? Xn equals 1 by n. Xn equals 1 by n. So what is limit xn? Limit xn equals limit 1 by n means 0. Here limit xn equals 0, but the series sigma xn need not be converges. Means the series, since the partial sum does not converges, therefore the infinite series sigma xn does not converges. That means when limit xn equals 0, it need not be implied the corresponding infinite series converges. So the reverse inclusion of nth term test does not hold, need not be held. May be held, but it need not be held. So the nth term test is an important one. There is a simple test for test the convergence of a series. If sigma xn converges, then limit xn equals 0. But by using this example, we prove that its reverse inclusion need not be held. Enough. Okay. Now, next we consider the Cauchy criterion for series. What is a Cauchy sequence? We know Cauchy sequence is a sequence xn with a modulus of xn minus xm. Xn is said to be a Cauchy sequence. Secant xn is Cauchy if modulus of xn minus xm strictly less than epsilon for all n m greater than or equals a particular stage capital N. Agreed. There is a Cauchy sequence for all epsilon is positive. So what is a Cauchy's criterion for convergence? Means every Cauchy sequence converges. So what is the Cauchy's criterion for a series? Here Cauchy's criterion means Cauchy's criterion. That means if the series sigma xn converges if and only if for all epsilon positive there exists a natural number k such that modulus of Sn minus Sn strictly less than epsilon for all n m greater than or equals this k for n. What is Sn? Sn be the mth partial sum of sigma xn. What is Sn? Nth partial sum of sigma xn. So for all n comma m greater than or equals k, so here n comma m greater than or equals k, also m greater than n. Okay, Sn. Then Sn minus Sn strictly less than epsilon. So this is the Cauchy's criterion for the convergence. So sigma xn converges, the infinite series sigma xn converges if and only if for all epsilon is positive there exists a natural number k with a m greater than n, and for all n greater than or equals k, modulus of Sm minus Sn less than epsilon, where Sm and Sn be the mth and nth partial sum of the given series. Modulus of Sm minus Sn when m greater than n means it is what remains there? It is xn plus 1, modulus of xn plus 1 plus xn plus 2 plus etc. plus xm strictly less than epsilon. That's the actual meaning. Okay, right. So this is the Cauchy's criterion. Now, come to a result. Let xn be a sequence of non-negative real numbers. Let secant xn be a sequence of non-negative real numbers. Non-negative real numbers. R plus union 0. Okay. Then the series sigma xn converges. Sigma with respect to n xn converges if and only if the sequence S equals Sn is bounded. What is Sn? Sn with the nth partial sum of xn is bounded. Secant xn with a sequence of non-negative reals, then sigma xn converges if and only if its nth partial sum S equals Sn, nth partial sum is bounded. How this prove? For so actually, as before going to that one, how to prove this one? What is sigma xn? We want sigma xn converges. Let sigma xn converges. Sigma xn converges means its partial sum Sn also converges. We know that. Let Sn be the nth partial sum of sigma xn. So when sigma xn converges, surely its nth partial sum converges. So secant Sn converges. What is xn? Xn be the sequence of non-negative real means secant xn greater than or equals xn, not sequence, simply xn greater than or equals 0 for all u. Okay. Xn greater than or equals 0 means what is Sn plus 1 minus Sn? Sn plus 1 minus Sn means what is Sn plus 1? Sum of the first n plus 1 sequence. Sum of the n plus 1 partial sum. Sn sum of the nth partial sum. So Sn plus 1 minus Sn remains means it is xn plus 1 that is always greater than or equals 0. That means Sn plus 1 greater than or equals Sn means secant Sn is an increasing sequence. Secant Sn is increasing means it is a monotone sequence. But by the monotone convergence theorem, secant Sn always convergent. Secant Sn convergent by monotone convergence theorem, secant Sn convergent if and only if it is bounded. So secant Sn convergent if and only if it is bounded. Agreed? Sure. Sigma xn converges. Sn be an increasing sequence. So Sn be a monotonic sequence. So by monotone